this part we're going to be deriving the formula for a circle, like the area of a circle. This will not be an integral form. This will actually be easy. You can simplify it to pi radius squared without a ton of trig substitution and stuff like that. So, always such a circle tool. I don't believe there is. Let's say you just have a circle, and you have its center point right here, and this length is r. And then you can bring this part down right here, and you can create two triangles where this little bit right here is equal to theta. Actually, I can get it a bit more. Theta, this little bit is equal to theta. And that means that this part also has to be theta, because using the congruent parts, congruent triangles are themselves congruent because this length is r and this length is r. And so we can find this height, a little right here. You can write that as, this would be a cosine, by the way. So before we do that, we're going to have to get into a little bit of, there's a little bit of housekeeping. So we're going to have to define how to do this. So 360 degrees, by the way, over theta is equal to n, where n is the number of sides. So, and the smaller and smaller theta gets, the more precise it's going to be, because what we're going to do is we're just going to add up all these together. So it is not going to be. So cosine of theta is equal to adjacent over hypotenuse. So there is, this is not r, by the way. This little bit is not r, because as you can see, there's like a little line right here. Just like ignore that little bit. We're just going to represent that as like this little side right here. It's just x. Okay. So let's do r cosine theta is equal to adjacent over hypotenuse, which is r, times r, because this little bit right here, these two can cancel out. And that means that r cosine theta is equal to a. So this length right here is r cos theta. So there you go. And then we can find this length right here using the same thing except for sine. So r sine theta is equal to, it's opposite over hypotenuse, b times r. That means that r sine theta is equal to b. That's supposed to be b, by the way. All right. So now we have these lengths determined. We can find the area of this little triangle right here. So let's do that. So it's base times height divided by 2. So let's do that. So the base we'll just say is r sine theta. So we have r sine theta times r cosine theta over 2. Because we're finding the volume of this. So you have to divide by 2. And then we put that into here, and you have to multiply by the number of sides, so that would be 360 degrees theta. And of course, it is taking the limit of as theta approaches 0, because as theta approaches 0, the smaller and smaller these triangles are going to get. So we take the limit as theta approaches 0. There's a lot of limits. So there we go. And you can simplify it. So let's simplify that real quick. And so that leaves us with 180 squared r squared times 1 times 1. This is how my that makes sense. And we have 80 r squared. Don't forget these are degrees. And obviously, anybody who knows radians, 180 degrees is equal to pi. And that is our formula. There we go. So that's the derivation of that. That's supposed to be it's supposed to be theta. So yeah, that's the easy way to do it. Now let's get to the integral way to do it. And the integral way to do it is a lot more complicated because you do have to deal with the trig substitution integral. However, I've already done that in another video. But what I did not tell you guys about is that how that can lead you to define the volume and hypervolume of specific spheres in higher than 2 dimensions. Like I did it for 4D sphere and the 5D sphere. 5D sphere was way easier because you didn't have to do the square integral. Anyways, yeah, we're gonna do that. Hello. So we just finished deriving the formula for the sphere and using another way that is not integral form, and we can use that to derive the formula of a sphere. Did I say that? What I just did was derive the area of the circle. Anyways, we got pi r squared, the volume formula. Let's start fresh. So we have the integral from 0 to r, little r. So I'm gonna call it little r above. It's like this little bit right here. It actually doesn't matter. Actually, I just read it. It's the same radius technically. So yeah, we can represent this as big R, and then we have pi, and then we have square root. Because of course I forgot to put the square root right here. Where r is just equal to the function, so square root of negative x squared plus r squared dx. And don't forget to square this bit. Also, we have to multiply this by 2. I just realized because it's since like all this is getting filled in, since it's a radius, you have to do the other side too. It'll be much easier if you can see my cursor. Alright, so there's the formula. It's actually a very easy formula to evaluate, so you do it right here, integral. So let's just plot the pi. So 2 pi 0 to r, and this is the square root of negative x squared plus r squared dx, and we can just use this in the power. So we have 2 pi negative x cubed over 3 plus r squared x ranging from 0 to r. And so let's evaluate that. So we have 2 pi negative r cubed over 3 plus r squared times r, that's just r cubed. I don't need to put it over there, but it is basically that. And now we just add, so we just have to simply multiply both sides by, or just by 3. So you have 2 pi negative r to the third power 3 plus 3r 3 over 3. And here we go. So these are like terms. They're technically both constants. So we have 2 pi 2r 3 over 3. And I'm sure you guys can already see what's about to happen. So let's just represent this as 2 pi. Well, these two go to 4. So we have 4 r cubed over 3 times pi. And let's actually utilize this space over here. That is equal to 4/3 pi radius cubed. And there we go. That is the formula for a sphere. And you can use the same method to create derive the formula for any sphere. And what we're going to do is use the same thing. They use this thing called the spherender method. So a spherender, like a cylinder, is a cylinder, but the top and bottom faces are circles. But a spherender is just a 4-dimensional sphere where the two top and bottom faces are spheres. So instead of using the for this part, instead of using the formula for a circle, you can use the formula for a sphere, and that'll give you the integral for the formula of a hypersphere, the hypervolume of a hypersphere. However, that integral is much harder to calculate because you do have to deal with a double square root, in which one of them is multiplied by the variable that you're integrating with respect with. It's just kind of a nightmare of integration, but don't worry, I've done it and I've already proven it and it does work, and don't worry, there'll be a juicy time lapse that I hope. Anyways. Alright, so now we got to the part where we're going to find the hypervolume of a 4-dimensional sphere. This is the integral for it. It's a very hard integral. And it is using the same thing that I did earlier, except we're using the spherender method like I mentioned. So, yeah. You guys ready for nice sauce? 15 minutes. the formula. Sorry. Yeah, so this integral simplifies to this. I hope you enjoyed. I bet it's gonna be a nice time. Alright, so now I bet you're wondering, how does this get into our main extension of 2 plus 2? So what I'm planning to do is take the formula right here of 40 that we have evaluated previously and solve for r. So let's say this is equal to 8. I don't think we've done that yet. Is there a number that we haven't done? Let's go 5. Alright, so solve for r. Now here's where it gets interesting. So we take the integral. So here's the integral. And yeah, and if you play an r for r to be equal to the 4th root of 10 over pi squared, should be equal to 5. I assume that's the integral. I just turned it based off memory. And yeah, so there you go. That's how it integrates into our main extension. And of course, we can find a 5 somewhere like that. Super easy. Hope you enjoyed this little bit of easy math. Hard. Don't worry. I bet the time lapse was worth it. This took me hours to do. It's a very, very complicated integral, but I'm getting a little bit better with trig substitution. With x being equal to a sine x, so a sine theta. Goodbye. Make sure to subscribe, suggest music, and if you do like math, please let me know, and I'll maybe give you a shout out. Maybe.